This is one where you want to get that 2x squared out of the exponent position. And so you're going to natural log both sides before you do anything. So you're going to say, well, I have the natural log of y equals the natural log of 4 to the 2x squared. And then when you do that, you can pull this guy out, right? And so I can expand and say the natural log of y equals 2x squared times the natural log of 4, all right? Now I can take the derivative of both sides, the whole thing. The derivative of natural log of y is just y prime, which is what I'm actually looking for, over y. Over here, natural log of 4 is just a constant. Think of it as 3 times 2x squared, right? And so I can just leave that guy alone, that's a constant, and then take the derivative of this guy, which is just 4x. All right? I am looking for y prime, like that's my whole goal is to get y prime. And so I would then multiply both sides by that y. But instead of putting y over here, I'm going to put what y equals. And so my final answer for y prime is going to be the natural log of 4 times 4x times 4 to the 2x squared. Well, you can technically you have a base 4 and a base 4 here. So you see this, the base 4 here. This is 4 times x, right? So you have two base 4s. So you can combine those if you want to. You can say x ln of 4, right? So get rid of these two. That's what I just accounted for. And these two combined times 4 to the 2x squared, that's 4 to the 1, right? You can just, like bases, you add their exponents. That's 4 to the first power, 4 to the 2x squared power. So you wouldn't want to have x times x squared as part of your answer, right? And so you can simplify it that way. You can think of it as each piece of this. Ln of 4 times 4 times x. That's not simplified. Look at it that way and see what I mean. Like it would, this is tantamount to saying x times x squared is my final answer. Well, that's weird. Why would you do that? You would just say x cubed, right? Does that make sense? You're saying 4 times 4 to another power. Just do one base 4. Try to make all your bases the same. So I have, if I were to take this right here, okay? I have my x, I have my ln of 4, okay? Now I'm going to deal with a 4 to the first power times 4 to the 2x squared power. I just added my exponents. Same base, I added my exponents. So these two became 4 to the 2x squared plus 1. So the next one, you're doing the same concept. You're just going to end up with something other than a constant that gets pulled down. So you're going to still take the natural log of both sides. The natural log of y equals the natural log of x to the x squared. This is so you can pull it down. So I can now pull that x squared down in front. So I have natural log of y equals x squared ln of x. That's no longer a constant. So now I actually have a product rule going on here, right? Because I have technically I'm multiplying two functions. I'm multiplying x squared and ln of x. And so when I take this derivative on the right-hand side, I'm going to have to do product rule. So left-hand side, again, is easy. It's y prime over y. The right-hand side, derivative of the first, that's 2x times the second, plus the first, derivative of the second. All right? So I did the product rule. Derivative of the first, 2x, times the second, ln of x, plus the first, x squared, derivative of the second, 1 over x. All right, so I am going to simplify this, right? Because this simplifies to just x. So I'm going to have over here 2x ln of x plus just an x, right? Equals the y prime over the y. And once again, I'm going to multiply both sides by the y. All right. A couple things to show you what they did here. First of all, instead of writing y, I'm going to write what y equals. So I'm going to have x to the x squared times that 2x ln of x plus 1. I mean plus x. I'm moving ahead. All right. I can simplify this, believe it or not. In this group, you have an x in common, right? You see that? 2x and x plus x, right? Remember, if you have anything in common, you can factor it out. So I have x to the x squared times, and I'm going to factor out an x, which will leave me 2 ln of x plus 1. I can't pull the x out of the natural log because it's think of it as stuck together, right? That's the natural log of x. You can't factor an x out of there. But I can factor it out here and here. And I'm left with 2 ln of x plus 1. I factored an x out of each of those. And so that makes it easier to see that I have like bases. I have an x to the x squared, and I have an x to the 1. Well, what do I do when I have like bases? I add their exponents, right? X squared times x cubed is x to the 5th. I add their exponents. So that's what I'm going to do. I'm going to say, well, that's x to the x squared plus 1. Add their exponents, and you're left with 2 natural log of x plus 1. And that would be your final answer there, and the most simplified that you can get it. All right, for a period of time, an island's population grows at a rate proportional to its population. If the population was 1,312 8.5 years ago, and the current population is 1,651, what will the population be 6.1 years from now? So they've basically given you the same thing. So the CE to the RT. For this one, you're going to use what it is now. So 16, we're trying to solve for K. They didn't tell us our rate of growth. 1651 is what it is now. It started out at 1312, and that was 8.5 years ago. Okay? All right, so I have to find K if I want to figure out what's going on. So I'm going to divide both sides then by the 1312. And then I'm going to natural log both sides to get rid of that E. So I have the natural log of 1651 over 1312 equals 8.5 times K. So my K is going to equal the natural log of 1651 over 1312, all of that over 8.5. And I'm going to leave that K alone. Okay, I'm going to leave it alone and actually put it in my calculator that way, believe it or not, when I get to this. Now, here's the thing. There are two ways to set this up, okay? Originally, I set this up with a starting point of 1312. If you do that, your time has to be the 8.5 plus the 6.1, okay? So if you go back and start back at 1312, that was 8.5 years ago, and they want 6.1 years from now. So you're going to have to use those two added together, 14.6. Or you can do your starting point from now forward, 1651. It will be the same growth rate. You'll just have to use the 6.1 as your time. Okay, so I'm going to show you the difference in the two so that you do not do it one way with just a 6.1. That's going to mess you up. So if you're trying to find out what it's going to be 6.1 years from now, you can either start at the 1312 like you did here, e to that big old K, right, which is that ln of 1651 over 1312 divided by 8.5 times 14.6, all right? That's if I start at 1312, because 1312 was 8.5 years ago, right? Or you can also find it starting at 1651 and go e to the natural log of 1651 over 1312 over 8.5 times that 6.1, okay? Just make sure you don't start 8.5 years ago and use 6.1 years, okay? That's all I'm saying when you do this. Because the 1312 as a starting point was 8.5 years ago and they want 6.1 years from now. So if you start at 1312, you have to consider the 8.5 years that have already passed plus the 6.1 years going forward. If you start at 1651, you can just use the 6.1 years going forward, okay? Just pay attention to your starting value for these when you're figuring out your T, okay? Does everybody understand why I set it up two different ways? Either way should give you the same answer, approximately 1,947 will be the population. So in your calculator, you need to do 1651 times, I just did this one, times E to the, it's going to automatically do a power, right? You need to do an extra parentheses there. Do natural log, it's going to open a parentheses, 1651 divided by 1312, close one parentheses, divided by 8.5, close one parentheses, times 6.1, close the other parentheses. Okay? And then you should get it. Close another parentheses and enter.